Say, you know that in India the satellite is launched from Sriharikota, and in the other countries it is French Guyana. Why it is to be launched there? Look at the principle. That is the principle of launching the satellite. It is the Earth. Say, from one of the highest point in the Earth, if you throw a stone with a lesser velocity, it will reach the ground at this point. Just if you throw the stone with some less velocity. If you throw it with still higher velocity, it reaches that faraway point. If you throw the stone with greater velocity, then it starts revolving around the Earth. And that velocity we call it as a orbital velocity. If you still throw it with a higher velocity, it will escape from Earth's gravitational pull, and that velocity we call it as a escape velocity. Whether the planet revolves around the Earth, that's the body you have thrown revolves around the Earth, or it escapes from the Earth, depends on the amount of the velocity that you are giving. That's very important. If you give a higher velocity, that body starts revolving around the Earth. That's called orbital velocity. If you provide still higher velocity, that will escape from Earth's gravitational pull. That's called as an escape velocity. And now we are going to derive an expression for orbital velocity, which is equal to root of gr. And escape velocity is given by root of 2gr. And root of 2 into root of gr means it is v0. Remember, this is what we are going to derive it now. First we derive an expression for the orbital velocity. Orbital velocity. What's the principle behind the orbital velocity? Remember, when you throw a body, for the body to revolve around the Earth, you must be knowing that for any body to revolve around any body, centripetal force is required. Here, who will provide the centripetal force? Earth gravitational force would provide the centripetal force. Remember, it's a basic principle which I was explaining in motion in 2 dimension. You know that for any body, it is Earth. For any body to revolve around the Earth, this is the, let us say, body of mass m revolving around the Earth with a velocity v. And if r is the radius, for any body to revolve around the Earth, you know that the centripetal force is required. Who will provide the centripetal force? You know that Earth has a lot of gravity. That gravitational force would provide the centripetal force. Therefore, what's the principle of orbital velocity? You should say that the centripetal force required for the satellite is provided by Earth's gravitational force. Very important. What is the formula for the centripetal force? mv squared by r. What is the r? Radius. Since it's a different velocity, make it as a v0. And that's equal to the gravitational force. What is the formula for the gravitational force? Gmm divided by r square. So you cancel off this m on either side. Cancel off one of the r. Therefore, your v0 square is equal to gm divided by r. What you want is orbital velocity. Your orbital velocity is given by root of gm by r. This is the very, very important expression for the orbital velocity. This is the expression for the orbital velocity when this satellite is very close to Earth. Suppose if the satellite is at a height h, at a height h. So your orbital velocity is given by v is equal to root of gm divided by r plus h. If it is close to earth, what is the value of h is equal to 0, then you will get this value. Okay, gm by r. Remember here, but your g is equal to gm by r square. So, which implies your orbital velocity v naught is given by root r. In the place of gm, you can write gr square by r. What are the r get cancelled? You substitute in the equation number 1. Therefore, what is the formula for the orbital velocity? Root of gr. Very, very, very important. When it is very close to earth, when it is at a height h, your v naught is equal to square root of g into what you should write? R plus h. Remember, it's very important. This is the expression for orbital velocity in terms of g, m and r. This is the expression in terms of small g and r. When it is very close to earth, when it is at a height h from the earth. When it is at a height h from the earth, you must add that h for the r. Okay, it's very important for 5 marks. Sometimes the question will be asked, what's an orbital velocity? Orbital velocity is the velocity with which a satellite revolves around the planet. Here is the planet. Planet is an earth. Okay, now this you can call it as equation number 2. Now you look at that. If you substitute the value for g and r, your value comes out to be root of gr. If you substitute this value, and it comes out to be 7.9 kilometers per second. That is for the Earth's satellite, when it is close to Earth. For the satellite to revolve around the Earth, how much of velocity it should possess? 7.9 kilometer per second means per second it should go for how many kilometer? Approximately 8 kilometer means it is 5 miles. 8 kilometer means from here to what you can say the Brigade Road or MG Road, there's a distance. In 1 second it should move to that distance, and that velocity we call it as a orbital velocity. Okay, it's very important. Please make note of this.